Okay, so we had covered the first 3 sections, and today we'll start from the 4th section, so using atomic vector. And for here, we'll review some of the important tools for working with the different types of vectors we had learned last weekend. So we'll see how we can convert from one type to another and what happens, and when that happens automatically. And secondly, we will see how to tell if an object is of a specific type of vector. And thirdly, we'll see what happens when you work with vectors of different lengths and how to name elements of a vector, and lastly, subsetting. So coercion is we can coerce or convert one type of a vector into another in 2 different ways. So one is explicit coercion, and we do so by calling a function such as the as.logical, the as.integer, the one for double, and as.character. But before doing so, we are advised to check the type of the vector. And we can do so, for example, by tweaking your read read.csv from the read.r package, the call type specification. And the other type of coercion is implicit, and here we can do so by using a vector in a specific context that expects a certain type of a vector. An example is when using logical vector with a numeric summary function, or using a double vector where an integer is expected. Our focus in this discussion will be implicit coercion, because explicit coercion is relatively rarely used in data analysis, plus it's easier to understand. So an important type of implicit coercion, it is using a logical vector in a numeric context. And what this means is the true is converted to 1 and the false is converted to 0. So when you sum this logical vector, we'll be summing the number of truths, and the mean of this logical vector, it is the proportion of the truths. So here we have an example. We have X, it's a sample, and Y is created from X following this condition. So when we take the sum of Y, we'll be looking at how many are greater than 10. And if we check the mean of Y, will be what proportion are greater than 10. And if we do so, we see that the sum is 51 and the mean is 0.51. Yeah. Or some code that relies on an implicit coercion in the opposite direction. This is now from an integer to a logical. And we learned of the if function. So if the length of X is something, and here the 0 will be converted to false, and everything else will be converted to true. So to easily understand what is happening on this R chunk, it's best to specify that the length to be greater than 0. So note 1 is another note below, that when we create a vector containing multiple types with the concatenate function, the most complex type always wins. So this was such an aha moment for me. So we have here an example where we are looking at the type of true and an integer, and we know that the logical is simpler as compared to the integer, so the integer wins. And if we look at the type of an integer and a double wins. So I was trying to understand why the double wins, and I thought it was because an integer is created from a double, perhaps, or if I looked at the image we had studied on the section showing the complexity hierarchy of the atomic vectors, we saw that an integer is less complex than a double. And we'll look at this example where we have a double and a character. We have here a character will win, and is as shown on this output. So another note is that an atomic vector cannot have a mix of different types, since this is a property of the complete vector and not the individual elements. So if you want to have a mix a mix of multiple types, in the same vector. And then we use a list. Going to the next section of test functions. So suppose we want to have different things based on the type of vector. We can check that type of vector using the type of function as seen above, or we can use a test function which returns a true or a false. So it is not recommended to use the base R functions. This is the is.vector and the is.atomic. We will see a good explanation in the exercise. So, but instead we use these underscore functions from the PAR package that have been summarized in this table. So for example, so we have these are the atomic vectors, and now this is the list. This is underscore logical, this will return true, and for the rest will be false because this particular atomic vector is a logical. And if you look at the is underscore atomic, it returns true for all the atomic vectors, and it will return false for the list. And lastly, if we see the is underscore vector, we see that it returns every, like all the atomic in the list as true. Okay, so we move to the next section, which is colors and recycling rules. So not only does R implicitly coerce the types of vectors to be compatible, but it also implicitly coerces the lengths. And this is called vector recycling. And this is because the shorter vector is repeated or recycled to the same length as the longer one. This is mostly useful when we are mixing vectors and scalars. And let's note that R doesn't have scalars. Instead, it's a single number. A single number is a vector of length 1. I think John had mentioned the last discussion. So since we don't have scalars, most built-in functions are vectorized. This means that they will operate on a vector of numbers. Therefore, these two codes can work. So we have a sample of 10 and we're adding 100. So for each sample, we'll be adding 100 as we see here in this output. In this second example, where we have a sample from a uniform distribution, we want it to be greater than 0.5. So we see that we have several false and truths. So what would happen if we add two vectors of different lengths? So we have the 1 to 10 integer and 1 to 2. And we see that, so here we'll take 1 plus 1, it returns 2. So the next is 2, we take 2 plus 4, it returns a 4, and so on. So you see this, the shorter one is being recycled, and we add it to the first atomic vector. So like what you said, that the R expands the shortest vector to the same length as the longest. This is what we call recycling. So, but what if the length of the longer is not an integer multiple of the shorter one? So in this example, we have 1 to 10 and 1 to 3. Previously, we had seen 1 to 10 and 1 to 2, and 2 is a multiple of 10. I think if we do 2 times 5 gives 10, but then there is no any whole number, like an integer, that 2 is a multiple of 10. So it will give an output, but we'll have a warning. And now, hence we have been told that vector recycling can silently conceal the problem. Hence, the vectorized functions in the tidyverse will throw errors when recycling anything other than a scalar. And we can use the rep function to do recycling ourselves. So for example, here we have got a table with 2 columns, X and Y, and for X is 1 to 4, and for Y is 1 to 2. So here we see that these are of two different lengths. And if we run this, we'll have an error, and the error is these table columns must have compatible sizes. So it means they have to be of the same size. So if we look at the second example where we have x is 1 to 4 and the y is, we're repeating 1 to 2 and then 2 times. So we have, as we see here, we have 1 R2 and 2 R2. And so if you look at this other example, we have, I think this is usually the argument each is equals to 2. So if I understood correctly, this is one and the same thing. Okay. So is there any question before I proceed? If not, I can. So naming vectors, we can name all types of vectors during its creation with the concatenate function, as you see here. We have the x, y, and z as we see here, or we can use the set underscore names function from the par package. And so here in this example, we have an integer 1, 2, 3, and they have been named ABC. As we look at the output. So if you may ask yourself why we name vectors, these are useful in subsetting, which we'll see below. So to filter vectors, we use the subsetting function, is the block bracket, and we call it as such, that is x, the block bracket, and then the element that you want, or rather the vector that you want to subset. And there are 4 types of things that you can do when you subset a vector. So the first one is a numeric vector that contains only integers, and this must be either all positive or negative or 0. So if we subset with positive integers, this keeps the elements at those positions. So we have x is 1, 2, 3, 4, and 5. When we subset using the numbers themselves, remember here I've said the integers, we can subset 3, it will return 3, 2 returns 2, and 5 returns 5. As you see on this output. If we repeat a position, we can actually make this output longer than the input. So here we have x, we are subsetting 1 and 1, 5, 5, yeah, 5 and 2, and we see that this is actually longer than the input. So for the negative values, we use them if we want to drop elements at the specified position, sorry. So here, if we have -1, -3, and -5, we know that, or rather it will return 2 and 4 only. But if we mix positive and negative values, we have an error that only zeros may be mixed with negative subscripts. And so this, it's returning no values. Oh, sorry. Yes, it returns this an error, but if we want to return no value and then we say x, the subsetting functions then 0, so it returns no value. So in the book, it's rare that this is useful if we want to create unusual data structures to function with. Yeah, I didn't understand that statement.
The cases I can think of where I want to create like a character 0, it's like placeholders, basically. Like if you want to set something up that this should be a character. So like if you then use that to combine with the number 1, it would turn the number 1 into a character because it's got a character in it, like we saw before, where it uses the most complex thing. It's things like that. I can't think of a really great example right now, but it does come up fairly often when you're coding a lot. That yeah, it's just if you want a thing that I think just thinking of it as a placeholder is the best. Like I think that's the most common use case that I have. The other thing I wanted to interject with is I still don't have a way to pronounce the brackets that I'm really happy with. I had a whole conversation on Twitter and took suggestions, and nothing's great. One option that I use is where. So when it's a single bracket, you think of it as where, which kind of works. Like X where it's the first, second, or third, or X where, and we're going to see that you can do it by other things. Someone else recommended slice for the single bracket, that because you're pulling out a slice of the data from the vector. I don't think either of those is super easy to remember yet, but I'm working on that one because the difference between single bracket and double bracket confuses people a lot. And I think if I could find a good way to pronounce it, that would help, but I haven't found one yet. So we'll see.
John, if you don't mind me expanding, isn't the single bracket global where the double bracket is internal to the function? So if you're looking at a list as an example, a single bracket is looking at the entirety, whereas the double brackets are more specific to the variable you're looking for. Does that make sense? The single bracket is global, larger, more inclusive, whereas the double brackets are inclusive. Is that right?
Somewhat, yes. Like
Okay.
it's the more bracket. Well, you can only do one or two, but as you put in more brackets, you're drilling in further. So which we'll see in some things down below, and just as you read the sentence, X bracket 0. That's not fun. That's not a good way to say that. But I don't have a good. Like, I don't know, a good way to just read the sentence, and that's my thing. So I'm trying to find it.
Okay. For purpose of this discussion, I'll use where. Okay, so the second thing that you can do is subsetting with a logical vector, which keeps all values corresponding to a true value. This is often used in conjunction with the comparison functions. So we have this example where it's we want to subset this particular, and we see that this is not ISNA function X, and this returns all non-missing values of X. And if we have this other one, we see that this returns all even or missing values of X. Yeah. So the third thing we can do, sorry.
Just
yes.
These ones are where makes the most sense, like X where
yes.
not is NA X where X modulo 2 equals 0. Like that's where the where makes sense, or is easy to read. But in other cases where it doesn't really make sense. So
okay,
getting there.
So we have seen how to name vectors, and like I mentioned that we can subset with a character vector. For example, here we have X is ABC1, and then we have as this. So X where X, Y, and Z, and D and F, D, E, F, we see that it returns 5 and returns 2. We can also use a character vector to duplicate individual entries. So this means that we'll have, so if we have the X, Y, and Z, and then repeat it, and also the D, E, F repeated, then it returns this. So sorry, X where X, Y, Z, and D, E, F. Okay, the fourth thing we can do is the simplest type of subsetting is nothing. So this is X where it's an empty, like an empty set, yeah, which returns the complete X. So this is mostly useful when we're subsetting matrices and other high dimensional structures. But in our discussion, we haven't covered the matrices. However, this is important when we can select all rows and all columns by leaving that index blank. So if X is second, we can do X where we are returning the first row, and then we want all the columns to be selected. So this selects the first row and all the columns. So if you want to read more about the application of subsetting, you can check this subsetting chapter in the advanced book. The link is provided here. So what could be the difference between the single bracket and the double block bracket? So these ones, it extracts a single element and always drops the names. So we use it whenever we want to make it clearer that we are extracting a single item, as in a for loop. I think we'll be discussing for loops in the next chapter.
I have a quick question.
Yes.
What does it mean it always drops names?
Okay. So if I understood correctly, it extracts the component itself. There's a very good example below that is showing the pepper shaker, yeah, and how it, like, if you use the double brackets, it pulls out the components themselves. John or Ryan, please, if you want to add more.
Sorry, I was muted. Yes, so the double bracket is getting down to like the thing itself, not how it is named in this vector. And so that's where you drop the name because you're getting to just the value. And this, God, I don't even remember because none of them worked well to me for the double bracket. I'm trying to find the thread to see if I can remember what we came up with, because none of them really, it's like only the is a way I said it, or pluck, I guess was how someone else said it, where you're plucking. The problem with using slice and pluck is those are functions in the tidyverse that have they have related meanings, but not exactly the same thing. But it's getting to just like exactly the thing you specify with the double bracket. And it looks like Ryan has a thought.
Well, yeah. So if single brackets are is it going to return the type? So like everything that matches the type. So a list of lists, right? So you've got all of this, various homogeneous, am I saying that right? Yes, homogeneous grouping of data types. If you pass the single bracket, it's going to pull out the single type, whereas the double bracket is going to be when it matches the value. Is that correct? So like if everything is an integer, or it's only going to extract everything that's an integer, or everything that's a character, or anything that's it
depends. It depends. Yeah, depends what your where is, basically. So, and it also depends on the type of object that you are subsetting. So that makes it even more complicated.
Because you're subsetting, you're not telling it the type, you're telling it an index position, right?
Right.
So it wouldn't know. Okay.
Well,
so I think I was just confused about what names means, because I read through the pepper shaker example, which I thought was excellent. It was so cool. But so names is an attribute, or
yes.
So I get that it's some kind of a hierarchical level that it's ignoring when you use the double brackets, right? So, okay.
Yeah, so I sent 2 examples, which this is getting into even more complicated because it's using a data frame, which is technically a type of list. And so it's like it's getting into some fancier subsetting. But I think when you're working with the data frame, the difference between single and double becomes a lot clearer, because when you do the single named thing, the empty cars, where the name is MPG, you get the column that is named MPG. So you still get it as if it's, within the data frame context. When you do the double bracket, you get the contents of that column, but you don't get there's no longer the structure that makes it a column. It's just the vector of numbers that are in that column. I don't have a good one handy. Let's see. Okay, let's do sorry, I'm not typing fast enough for okay, let's see if that does something fun to work with. Yeah, so I made a quick data set with that, and that way you have a vector character vector of month names or of months, and the names of that character vector are the abbreviations. And then so you could do things like months, Jan, and we can see if you run that I guess I can paste what it does. You get the named, you get like a mini vector back, or a miniature, a subset of exactly the thing. So the thing that I started with was a named character vector. I get back a named character vector. It's just a much smaller named character vector. But if I put in 2 brackets and copy and paste that, I just get a character vector. I get the contents of that spot, not like the same feel, all those same properties. And if this had, I don't know, if this had other properties to it, the single bracket would keep those properties. The double bracket, or attributes, I guess is the word I should be using there. The single bracket would keep those attributes. The double bracket says, no, I just want the contents. I want the thing inside of there. It's really, I don't know, it's funny to me that subsetting is one of the most basic aspects of R and one of the most confusing things in R in my mind. It's just, it's this fundamental thing. It's probably done inside of almost every function that you use, under the hood. But it's still, it can be, I definitely still make mistakes where I'm like, oh, I should have double bracketed, not single bracket. And that's part of why I'm trying to like get it in my head with a word to use so that when I'm writing my code, I'm thinking of the right one. I mean, I say that it's not like it happens all the time or even that it comes up really all that often, because usually I'm using functions, not a simple subset, but it's this fundamental thing that can still be confusing, and I wish it weren't.
Okay. So going back to your empty cars example, could you say that, so the first one with a single bracket gives you the column, right? Versus the second one with a double brackets would give you the contents of that column. So is it sort of like the double brackets strips some of the identity column off of the thing that it's returning? So it's getting rid of some kind of layer of information that made that a column, I guess.
Yeah. So
yeah. Okay.
Trying to think. So there's let me try that, and then if I do, let's see if this does it. That gets closer. So this is gonna start. We're gonna go into some crazy craziness, but so we're getting rid of properties. So one of the properties when you do the MTG or empty cars with just MPG, you're getting a column, which is a type of list. So let's unlist that, and we see, oh God, that pasted awful. Run it yourself. Or even if you unlist it, you get a named vector of a named numeric vector, and we don't want that, and so we also unname. And then when we unname and unlist, we get what we would have gotten with the double bracket. Or another way to look at that would be like single is, so if we do, I'm starting by just creating this single where I just do the single thing. And if you do, was it attributes? Yeah, there we go. Oh, so close. That almost totally did it. That if I do, if I just nuke all of the attributes of that thing, I almost get to what the double bracket gave me. I'm still within, I'm still in a list of 1, so it's not quite exactly there, but like the double bracket is just like really reaching down in and pulling out the thing,
right?
Not the, yeah. I hope that's helping.
Well, I got a really dumb analogy, but it might help in Sandra's case. So if you're looking at a cell in a microscope, you're, let's say, power 10, you're getting the whole cell itself. If you change to magnification, 100x, now you're looking inside the cell. It's still a grouping of the body itself, but you're being more specific in your focus of what you're zooming into. Is that a bad analogy?
No,
John,
that actually is good, because that's exactly what I was thinking. It almost looks like, like a more intense focus or a closer look, or in more detail. But I was just wondering, so, like if these do different things to, I don't know if it's just like the data structure or the identity of the data, then sort of what exactly was it getting rid of when you're, you know what I mean? So I get the process of it, like what is extracting, but I was like, so within R, like what, I'm sorry, I can't formulate this because I don't have a working knowledge of how this might work behind the scenes, you know what I mean? But I think that, yes, so it's getting rid of some sort of information that the higher level contained. Or maybe that's, that's wrong and that's not exactly how it works. But I'm sorry, this is, I think, getting off on tangential things.
Yeah. Like all of this is true. I mean, most of the time, all you have to really think about is you do a single bracket to to get all of the things that fit some criteria that you give it, and you do double bracket to get just the thing inside of all that. And usually it comes out to, like, you use one bracket when you want lots of things and two brackets when you want one thing. It's not exactly that, because it could be one vector, could be the thing that you want, but it's getting there. But I think, if you think about that, the double bracket like really strips things off. Like, oh, that would probably be a mess to paste, but let's try this. str is a function to look at the structure of an object. And so I have my months thing from up above. When I look at the str of months with the double bracket one, it's getting just that character vector January. And when I do the single bracket, it's still, again, like we saw, it's getting the named character bracket January, and it keeps that name's attribute. So it, just reinforcing everything that we've been saying, that keeps more of the stuff with the single bracket. And I'm sure there's I guess I should look at that. Like, I'm sure there's a more formal definition that might help with this. So one thing that you can type, anything, like, you can get help on pretty much anything in R, but you have to know to put the tick marks around it. So for here, I was trying to see if they give it a name or explain it, but I don't see the difference. Yeah, they even, they list it as single bracket selects more than one element. The other two only select a single element, but single element means, again, I guess, okay, think about, like we said, R doesn't know what a scalar is. So in R, a single element is a vector. I think that helps solve or get to the solution of the puzzle. So when you were saying that we're selecting a single element, it can still be a long single element, but it's just a vector, because R doesn't know the difference between a length 1 vector. Well, knows that the length is 1, but other than that, length 1 vector and a length 3000 vector is the same thing as R is concerned, as far as R is concerned, and those are both one thing, one element.
Okay. Can I ask one last question? So, for example, like, I was just thinking of maybe a time when you would want those double brackets to, for example, say that, in the third position of your data frame or something, you have a list, right, that has some elements. So you just want the values in that list to be able to perform some kind of mathematical operation that you wouldn't be able to perform on a list, right? Because,
Right.
or I don't know, you can't do math on a list, but you can on the numbers in the list or something like that.
Yeah, like a lot of, so the other
Okay.
complication is that a lot of functions kind of handle it for you and go, oh, you meant to give me a
Oh.
character vector, or you meant to give me an integer
Yeah.
vector. Let me pull it
Yeah,
out.
yeah.
But yes, I mean, that is what it is, that when you're trying to, you know, like you don't want the names are going to get in the way of whatever
Mhm.
you're doing. You want to see, are these things the same? Ignore the fact that they have names, because I don't, you know, I'm just saying, did they come to the same values? Then,
Right.
you know,
right.
that kind of thing.
Okay,
Yeah.
that makes sense. Okay, thank you. Sorry to Lucy, please go ahead.
Yes.
It was an interesting discussion. Thank you both.
Thank you.
So we have the exercises. John, should I go ahead and cover the exercises, or we proceed to the next section?
I think pick out the exercises that you find the most interesting, and you know, let's try to finish this chapter today.
Yeah. So I'll pick number 2, because there's some statements that were given that I didn't understand. So carefully read the documentation of the is.vector function. What does it actually test for? And why does the is.atomic function not agree with the definition of atomic vectors above? So this was, I got the answer from the solutions link. In the is.vector, it does check whether an object has no attributes other than names. So if we have this list, it has got a list with 2 elements. We have got A is equals to 1 and B. If we look at is.vector of this particular list, it's true. Okay. And but any object that has an attribute apart from the names is not. So if we look at X is 1 to 10, and we have given it an attribute that something is equals to true. So we are calling this attribute true. And if we look at the x.vector is equals to this function, it returns a false. So if I understood this true is not a name, so hence it returns false. Okay. So to summarize, then the other one is the is.atomic function, which explicitly checks whether an object is one of the atomic types. So this, the logical, integer, and so on, or the null as well. So we have is.atomic is equals to 1 to 10, returns true, and this, when it's a list, it returns a false. I think it's similar, as you've seen, as the is_atomic from the bar package. So the is_atomic function will consider objects to be atomic even if they have extra attributes. Yeah, so if we check this is equals to true, I think the set names in these 2 functions can easily look at the solution, and it's well explanatory. Yeah. So recursive vectors, this is the lists. So the list can contain other lists, implying that they are more complex than the atomic vectors. So therefore, it is suitable to represent hierarchical or the tree-like structures. So if we want to create lists, we use the list function. And this is the first example. If we look at it, it has these 3 different elements in it. And we can use the structure function to assess the structure of the list. So here we see, if we look at the structure, we see it's a list of 3. Yeah, as you had seen. So I had seen the glimpse function, so I wanted to understand what could be the difference between the 2. and it seemed to be the same thing. Okay.
In this case, it's the same. Glimpse is it's kind of a friendlier STR for DataFrames specifically. It's aimed at giving you a quick summary of a table. But in this case, with a simple structure like this, it's the same. In fact, it might literally be calling STR. I'm not sure. What did I do? Okay. Yeah, I don't know for sure, but I don't know where those are hiding. Oh, helps if I don't misspell. But yeah, I don't have anything more to add on that.
Okay. Okay, so moving on, the list can also be named. So we have got the three, a list of 3 elements, and the 3 have been named. And if you look at the structure, it returns the name colon the content in it. So it's a number 1, numeric rather, yeah. So a list can also contain a mix of objects, unlike atomic vectors. So we have a list containing a character, an integer, double, and a logical. And this can be seen if we look at the structure of this particular list. List can also contain other lists. So we have, this is a list that has got 2 lists in them. And if you look at the structure of this example, you see that it has the lists, yes, and then it also gives the elements in those other 2 lists. Yeah. So let's visualize how lists are. So if we look at this particular drawing, we have, yeah, so we have this example where x1 is just a list containing these 2 vectors, and we have x2 is a list containing 2 lists, and x3 contains an extra element and also 2 lists, So if you look at this, we have, this is the list 1, which contains 2 vectors, and x2, it contained 2 lists, and in the 2 lists contained 2 atomic vectors, and this is for list 3. When it has an atomic vector, then it has got a list with an atomic vector, and this the 3rd one, it is a list within this list. Yeah. So let's make a summary of that. So this list have got rounded corners like this, while the atomic vector has got a square corners, and so here the children are drawn inside their parent, and they have a slightly darker background to make it easier to see the hierarchy. If you look at this, the last one, we have so this list, the second list is darkest compared to the first one, showing it's inside this, and the very last list, it's darkest as compared to these 2. So we have the orientation of the columns, that is the rows of the columns are not important. And a row or a column orientation are picked to either save space or illustrate an important property in the example. So if I understood, it's that how they are arranged, it's not of importance, it's just to show, to illustrate that particular list. So we have seen how we can subset vectors. So how can we subset lists? And they can be done in 3 ways. So looking at this example here, where we have got the list containing an integer vector named A, one containing a character named B, the other one is double, which is a pi, and another one is D, which is a list. And if we want to subset, we can use this is the subset function, the where it extracts a sublist, and the results will always be a list. So if you look at this example here, if you're subsetting the 1:2, it will return the first two vectors in that particular list. So the first one was an integer with 1, 2, 3. The second one was a character, that is a string. And if we look at this, when we're just saying A, where we're looking at the fourth position, we'll see that, sorry, yes, the fourth is, yes, the element in the fourth position, we see it returns that list, which has got two atomic vectors, -1, -5. We can also do the same with a list containing a logical, an integer, or a character, as you've seen in the vectors. So the double brackets, or discussion, is stripping one. It extracts a single element component from a list, and it removes the level of hierarchy from that list. So if we look at A, where we're stripping the very first position, it's returning the integer 1:3. So this is the 1, 2, 3. And when we have the A where it strips the fourth position, it runs that list with the two atomic vectors. So a third way to subset, it is using the $, which is basically a shorthand to extract named elements of a list, and it works similarly to the double bracket, but here we don't use quotes. So if we do the E, so we have a named vector A. So when we do so, it returns the 1, 2, 3. And we can also do the same with the double brackets, where A is stripping the particular vector named A. So we have it as this. So this is to summarize the difference. It's that it drills down into the list, while the one single bracket, it returns a new smaller list. And we can compare, we can look at the example above using this particular visual representation. So if we look at this one, I was trying to understand where we are looking at this A, we are stripping to the fourth element, the fourth element, and we're looking at, I think we're looking at the first position, with just having it as a single bracket. But if you look at this, it returns the exact value of -1. So this is the list, yeah. Yes, John.
Yeah, so if you think about A4, A exactly 4, A double bracket 4 is getting that vector of -1, -5. Actually list, I guess it is, right? Because he said the rounded corner means list. So it's getting -1, -5. If you say just the first thing, you're getting a length 1 list that is -1. But if you say double bracket the first thing within that, you're saying I want to drill down and get exactly that element, which is it's always going to be a vector. So in that case, it's a numeric or integer vector that it's returning instead of a list.
One question. So say that -1, instead of being an atomic vector, was another list. Do you then just add more sets of double brackets?
Yes. So you would get the list. You would still get a list that was -1, and then you would need to add another double bracket to get down to the thing
Great.
inside of that list. Yep.
Okay.
Yeah, but I do. So you would get that single list. You couldn't get two different lists. You know, that list might be the list that gets returned might be a list of lists, but it's still just a single object. Versus with the single bracket, you can get back 2 lists of lists, for example.
Yeah. Okay.
Which would be a list. It's confusing. It's always confusing, no matter what I try to do.
Okay. So let's see the example using the usual paper shaker. So here we can, so this, sorry. So this shaker, paper shaker will be our list X. And if we select, like we want X, where it's the first position we are looking at, this is a paper shaker that contains a single paper packet, as you see here. And if we look at the X where it's 2, so it will look the same. So it contains just the second packet. But if we look at the subset, sorry, the X where it's 1 to 2, it will be a paper shaker containing 2 paper packets. And now if we look at the X, we're stripping only the first element, we see that it will be the 1 single paper. And if we now do this with the 2 double brackets, we are getting the content of the paper package. So this. And that was a very good example, sealed understanding. So we have an example, the exercises, you can go through them. So to draw those, this is just to mention, which is also in the solutions, these very awesome images, they were drawn using the diagram R package. So in the solution, that is, and we can render them in the GraphViz website to render those diagrams. So what I did wasn't so pretty. I didn't shade. So we can go to the next section. Those 2 exercises were pretty easy based on our understanding. So we can definitely do them on a free time. So for the attributes, any vector can contain an arbitrarily additional metadata, and this is through its attributes. And we can think of attributes as named list of vectors that can be attached to any objects. We can get and set individual attribute values with using the @s function, or we can see them all at once using the attributes function. So we have this example X, it's an integer from 1 to 10. We're giving it an attribute greeting, but then here we haven't named it. So it's still, I think it's the reason it's returning null. And we have this attribute, we are naming this greeting as hi, and the other one, it's for farewell, we name it as bye. And if we look at it, it has been named, this particular greeting has been named hi, and the farewell has been named bye. And at the first one, since we hadn't named it, it returns a null. So 3 very important attributes that's used to implement fundamental parts of R. These are the names, and so these are names that are used to name the elements of a vector, and you have dimensions, we short from dims, make a vector behave like a matrix or an array. And class, lastly, is used to implement the S3 object-oriented system. So this is note that we have learned names. We will not discuss matrices, as matrices are introduced in this book. So what we'll be discussing next is class. So class does control how a generic function works. And this generic function are key to object programming, since they do make functions behave differently for different classes of inputs. So for more details about that, you can check out the advanced R textbook. So let's look at an example of the as.date function. So we have So a particular interest is they use this use method. And the call to use method means that this is a generic function. And it calls a specific method, a function, based on the class of the first argument. So note that all methods are functions, but not all functions are methods. So to list all the methods for a generic function, we can use the method function, sorry. And if you look at the methods as.dates, it shows that these different methods that can be used. This was clearer in this example that if you have x is a character vector, so the as.date function will call the as.character. So I'm assuming if you feed this as.date with a character, it will use this particular method to convert it to a date. So, and if it's a factor, it will call it as.date.factor. So these methods that have been given here. John, did I understand correctly? I was not so sure.
Yes. And so it can be confusing if you're trying to understand how something works. Like that'll be something that, you know, I do a lot if I'm basically trying to make my own function that's kind of similar to some existing function. And it was difficult when I was first starting to learn things that I didn't understand S3. That you see, you know, you pull up the function to see how it works and it says use method in the name of the function. It's like, okay, that tells me nothing. Like, and that is how it is. Like in the thing that I have in the chat, I wanted to see how glimpse, what does it do by default? And so I had to go find the method for the glimpse method that gets called when it's not a data frame, is basically what the default is. Default's what it falls through to. Anyway, there's an example of a function there that I've called that way. Yeah, so we are running out of time. I do want to, I want to finish today. And I think that the two most important things that we have left, so we've seen that as date uses these methods. We don't need to go through all the details of how S3s work because we're not going to do anything with them in this book, and we can do advanced R if we want to learn about that. The things that are left that I think are really, you know, good, useful to know is the part about factors. That factors are actually numbers with names or with like possible values attached to them, but they're implemented as an integer with additional attributes. So yeah, exactly what's showing here, that x or a factor is an integer, but it has levels as an attribute. That is useful, that if you are working with something that has factors in it, when we remember that types get coerced, and so a factor is an integer, and sometimes it'll behave like an integer and surprise you, especially if some of your levels are named numbers. Like you might think that that one of the values that the second value of your factor is 3, but if that's the second level, then it would be 2, and it would be confusing. So knowing that factors are integers can be helpful for debugging when things get confusing. A lot of times, if you want to compare things with factors, wrap the factor in as.character to make it act like a character instead, and lose that integer info, because that can be confusing. So that's the first important thing. And then useful to know, it's almost like it's our trivia, but that DataFrames and then Tibbles on top of DataFrames are lists. They're a special type of list. They're lists of lists. So that's the other, just knowing that it can come up. It can, if you're seeing something default to using table or using list processing, it's because DataFrames and Tibbles are lists. And then yeah, Tibbles are an augmented data frame. I think we talked about that a little bit before. And And yeah, here, so we see the classes. This shows kind of the fall through that if there is an S3 method specifically for Tibble DF, then that's what will get called when you feed a Tibble in. If not that, it says, okay, how about Tibble? Because that's the second class. If not that, it tries DataFrame. And then if not that, it would try list because it is a list. And then finally it would go to the default. And so that's kind of the, like when you call a function and something kind of weird happens with a Tibble, for example, that would be useful to know. And then he also did a lot, or he talked about dates and date times, but we had an entire chapter talking about dates and date times, so I don't think it's really important to dig too deep into it. Here, use lubridate, or there's a new package clocks, which is, and I haven't learned it yet, but it's like an updated time thing. The point being, use a package to deal with times because times are hard. And I think that's the most important thing to get out of this chapter. And remember that time zones are complicated. And I think that's it. Was there anything else in the chapter that you wanted to particularly call out, Lucy? Or that anyone had questions about?
Yes, I have a question regarding the round function. So yeah, if I understood correctly, it's that the round function, when it's 0.5, it doesn't return to 0.4. It returns, sorry, it doesn't go to 0.6, it goes to 0.4. Yeah, what is happening? Because mathematically, I thought it would go to around 0.6.
Yeah,
Yes.
so this is R is special. The rule that most people learn in school for rounding when it's 0.5 is that you round up. That's what every computer does unless it's running R, and R does the special thing of you round to even, because that is slightly more statistically valid. Because 0.5 is right in the middle, so sometimes you want to go up, sometimes you want to go down. R does that by it always rounds to even. So if your number is, if the number before the 0.5 is odd, it'll round up. If the number before the 0.5 is even, it'll round down. That is very useful to know, because that can be super confusing if you're like comparing to like an equivalent function written in literally probably any other programming language. It'll round to E, or it'll round up on 0.5 versus R will round to even. It is technically better, like it's more statistically sound to round to even, but it like one thing it could cause is if for some reason you're trying to analyze like even numbers versus odd numbers in some data set, and depending how you round it, you might end up with more even numbers and be confused by how the heck did that happen? Well, it's because R is doing the thing that's slightly more sound statistically, and I'm sure that's in the help, and there's probably a whole like link to a paper or something. Yeah, and see details about round to even when rounding off of 5. So it's just that is a whole thing. Yeah, it's like, no, we're right. It talks about the standard that it's using. It's like, yeah, you're technically probably more right, but when no one else does it, it makes it almost wrong. You know, like it makes things confusing.
Okay.
All right, anything else?
Just wanted to say sorry that it took up time on tangents.
Oh, no, I think I was very prepared. I knew that was going to be a tangent to talk about.
Okay.
Like that was a thing that I went out on Twitter to try to get a good answer, because it is confusing and I still don't have a good answer, but.
And it's always good to know that I'm not the only one that's super confused. Yeah, I think you asked the question better than I could, because I was trying to figure out how do I even ask what I'm asking.
Good. All right. Oh, and I guess before we go, next week, chapter 21.
That is me.
All right. Iteration. Ooh, that's a good one.
Finding out that.
Yeah, my assumption is we won't get all the way through, but we will get started. I would try really hard to finish through, well, at least 1 and 2, and then, or 1, 2, 3, I guess, and then 4 is where it kind of starts being different. And so 4, 5, yeah, at least get through 3. That's what I would aim for.
I will try. I was
Yeah.
hoping to get like halfway through the chapter,
Right.
but yeah, it's a bit complex.
Yeah, so map is going to take a long time, or a lot of time. There's a lot of stuff to focus over there. And then walk doesn't take much time at all because it's just map without direct output. Yeah. Okay. We'll see where we can get.
Okay.
It's a good chapter though. Very, like, that's where conditionals and iteration, that's programming. Like those 2 concepts are what you need to make a thing that is a program. So, all right. I will see everyone next week.
Bye.